In this video, we're going to explore some different functions with the eventual target of explaining the differences between exponential and linear functions. So the scenario we're going to analyze is right here. Bob has a DVD collection with 23 DVDs. And we're going to look at two different options down here. So for option 1, Bob adds 10% to his collection every month. Okay, so if we want to take a look at how that works, we can first make ourselves a little chart. Okay, and if we say that the X value is the number of the number of months it's been, and the Y value is the number of DVDs he has, well then after 0 months he's got 23 DVDs. That's how much he started with, right? Then after 1 month, how many DVDs does he have? Well, he's adding 10%. So what we're going to have to do is multiply 23 times 10%, okay, times 10%, there we go, and that's going to be about 2.3, or exactly 2.3. Alright, so we're going to add that. So 23 plus 2.3 is 25.3. Alright, now the question is, after 2 months, is he going to have 2.3 more? So think about that for a second. And hopefully now that you've thought about it, you see that to find after 2 months, we have to do 25.3 times 10%. And that's going to be a totally different number. So figure out what that comes out to and then add that to the chart. Looks like that's going to be 27.8 is what goes here. So the first time we added 2.3, and the second time we added 2.53. So we added a different amount. We're adding 2.3 videos to begin with, and then 2.53, which is a little bit more. Okay, so after the third month, are we going to add 2.53 again, or a different amount? Seems like we're going to have to add a different amount now. Okay, and that's what makes it an exponential function. Each time you're adding a different amount. After 1 more month, we'd add a little bit more and get 30.6 DVDs. Okay. Now, if we were rounding these off, we'd have to say, this is 28 and this is 31. But for the purposes of this exercise, you can see the important part was that we weren't adding the same amount each time. Okay. So is that going to be linear or exponential? Yeah, that is exponential. And you'll have to excuse the handwriting. I'm still working on writing on the computer like this. Okay, but yes indeed, that is exponential. Perfect. Okay, so now let's go back and look at our other scenario. Okay, in the other scenario, option 2, we're saying that Bob adds 2 DVDs to his collection every month. Let's take another look at the chart and see how that looks. Where are we going to start? 23. 23 DVDs. After 1 month, well, he's adding 2, right? So we have 25. After 2 months, he's adding 2 more, so 27. And then after 3 months, he's adding 2 more, so 29. So all we're doing each time is adding 2. It's the same amount every time. Plus 2. So let's generalize this. If we're adding 2 every time, okay, then our equation is, then let's see, y, the number of videos we have, is equal to 23 to start off, plus 2 for every month. We're adding 2 every month. See, that's what that means. Plus 2 per month. times x, which would be the number of months. Okay, now this equation should be pretty familiar, and we know that that one is linear. So if we're adding the same amount each time, that's linear. Okay. Now, let's go to the graphs and see what these two functions look like. And the first one was y equals 23, or the linear one anyway, 23 plus 2x. Okay, let me zoom out a little bit so we can see it. There it is. It's going through the point 0, 23, that's the y-intercept, and the slope is 2. Okay, now let's look at the other one. Add a new expression where y equals 23 times. Now how much are we multiplying by each time in our chart? Go back and look at your chart. How much do we multiply by each time? Is it 0.1 for 10% to the x power? Let's see how that looks. Now if we look at this on the graph here, zoom in, that's actually decreasing. It's getting smaller. But if he's adding 10% each month, shouldn't it get bigger? What we forgot to do over here, we forgot to add 1. It's 1 plus the growth rate. So 1 plus 10% is 1.1 to the x power. Now when we zoom back out, we can see that it is indeed increasing. Okay, so we start here at 0.23 in both cases. And which one would you say grows faster? The one curving up or the one going straight up? It looks to me like the one curving up is growing faster. Let's zoom in and see if we can't analyze that a little further here. Okay, is the blue one always ahead of the red one? That's the question here. It looks like it is. But if you're not sure, you can always go to Edit and convert to a table. Aha, same thing on this one. Convert it to a table. Here's the x's and here's the y's. Now we start at 23 and go straight to 25 on the linear one. We start at 23 and go straight to 25.3. So after 1 month, the exponential curve already has 0.3 more than the linear one. Okay, and we can see that the amount that it's going up by here is different. The amount that it's going up by here is the same, up by 2 each time. Okay, and since this one is going up by 2 each time, we know that one's linear. Now what is this one doing? We can't say that it's going up by the same amount each time, so we can't say plus 2.3, because then this one wouldn't be the same. It's going up by a different amount. Okay, so what are we really doing here? How are we generating this list? Well, we're multiplying times 1.1 x number of times, aren't we? Because that's what an exponent is. 1.1 to the first is 1.1. 1.1 to the second is 1.1 times 1.1, and so on. So what we're really doing down here is each time we're multiplying times 1.1. Put that in parentheses. There? Yeah. And so down here, times 1.1. Right? So with a linear equation, you're adding the same amount. With an exponential equation, you're multiplying by the same amount each time.